So we're in section 9.5. And we're going to do what we call completing the square. So the idea here today is if we have a quadratic, some kind of quadratic expression, ax squared plus bx plus c. What we want to do is change it in a specific way. So we're going to make it so so we can factor the ax squared plus bx part as a perfect square. And what we mean by a perfect square is that it would be something like x plus some number squared or x minus some number squared. That's what we mean by a perfect square. Two things multiplied together like so. So we want to be able to factor the ax squared plus bx part as a perfect square. And this is going to let us do two things. We'll do two things with completing the square. We'll solve quadratic equations, and we can also use completing the square to find the vertex of a quadratic function. Now, we already have one way of finding the vertex, where we do negative b over 2a, and then plug that back in. Completing the square is another way to find the vertex of a quadratic function. Today, we're going to focus on solving. So the process of changing this thing so that we can factor it into a perfect square like so is called completing the square. So we're doing something to this to make it a perfect square. Now, it's an easy thing. The process of completing the square, the steps that we need to do, it's pretty easy. So for x squared plus bx, if we have a equals 1, we complete the square by adding b over 2 squared to it. So we take whatever b is, divided by 2, and square it, and then we add that to this. When we do that, we can then factor 2 x plus b over 2 quantity squared. So whatever this b over 2 turns out to be, x plus b over 2 squared, and that's what our thing that we've changed will factor to. So the big picture here is to complete the square, the main thing that we do is take b over 2, b divided by 2, and square it. That's our main step. And we'll have to do some other things to keep things arranged properly, but that's the main thing that we're going to do. All right, so we're good so far with our idea. All right, so let's look at a problem, problem you might see on your homework, a problem you might be asked to do that has to do with completing the square. So let's say we have x squared minus 20x plus c. And the problem says what value of c makes this a perfect square. So it's saying, what do we need to add to this quadratic to make it a perfect square? Well, what I'm going to do is say, well, A is 1, B is negative 20, and we want C is question mark. That's what we're trying to figure out. What do we want C to be? Well, we're going to complete the square. So B over 2 is negative 20 divided by 2, which is negative 10. And negative 10 squared, B over 2 squared, is negative 10 squared, which is 100. So if we add 100 to this, we want x squared minus 20x plus 100. So C is 100. And the reason now that this is a perfect square is this will factor to x plus negative 10 squared. So by adding 100 to this thing, we turn it into a perfect square. And now you could factor this by doing your cross in your box also. Two numbers that add to, or multiply to a positive 100 and add to negative 20. Well, that's negative 10 and negative 10. X minus 10 times x minus 10 is x minus 10 squared. And we complete the square by finding b over 2, squaring it, and adding it to this thing. Yes?
How come we don't put anything for negative 20x in the final factor?
Well, so x minus 10 squared, this is x minus 10 times x minus 10. If I multiply this out, I get this.
Okay.
So this is like what we did yesterday where we were factoring into two sets of parentheses. But when we have a perfect square, both the parentheses are the exact same thing. That's what perfect square means. Yes?
Are we always going to try to find the value of c?
No. Well, that's part of what we'll do.
Okay.
Finding this b over 2 squared is part of what we do when we solve or when we find the vertex. But this is, I wanted to do this example to show the process of completing the square. Okay? So let's look at another one of these, the same kind of problem, just so I can show the process again. And then we'll talk about solving using completing the square. So find C so that x squared plus 18x plus c is a perfect square. A problem like this, what it's translating into another way of asking the question is it's asking us to complete the square. So A is 1, B is 18, and we want to figure out what C is to make this a perfect square. Well, B over 2 is 18 divided by 2, which is 9. And B over 2 squared, which is what I want to add to this to make it a perfect square, is 81. So we're going to say x squared plus 18x plus 81 is what we want. C is 81. And this factors to x plus b over 2, x plus 9 squared. So I've added 81 to make x squared plus 18x a perfect square. Yes?
So when it says complete the square, the answer is just going to be that right there.
It would be okay. For this problem, you could say c equals 81.
Okay. And
Yeah.
then, but if we're just saying factor, then we have to factor.
Yeah, then then you do this. Yes?
When you find what it factors to, will it always be 1 for a?
For what we're doing, yes.
Okay.
Yes. And we'll talk about what we do when a is not 1 in just a second.
Okay.
All right, so we're good with this process of finding b over 2 and squaring it, adding to whatever we're starting with. That's the basic idea of completing the square. Now, one of the things that we're going to do with completing the square is solving. So I'm going to write some steps here. So when we solve by completing the square, just like when we solve by factoring, our quadratic must equal 0. We always have to start by it equaling 0. So we need ax squared plus bx plus c equals 0. We always have to start that way. If a is not 1, so we have some number here, we're going to divide everything by a. So if a is not 1, we have to divide everything by a first. Our next step is that we're going to move c to the other side of the equal sign. And we do that by adding or subtracting, depending on whether this is a plus c or a plus a number or minus a number. We just move c to the other side. Then we're going to complete the square on the x squared plus bx part. And we complete the square by adding b over 2 squared. And we're going to add that to both sides. Since we have an equation here, we're going to add this b over 2 squared to both sides of the equation. Then we're going to factor the perfect square. That's what we've done on our last two problems. We factored that perfect square to x plus b over 2 quantity squared. So that's what we did at the end of the last two problems, and we factored that thing that we ended up with to x plus b over 2 squared. Now we're going to, we have a square here with the x. We want to get x by itself. We take the square root of both sides. And when we solve by taking square roots, we talked about this at the beginning of the unit, don't forget the plus and the minus. Plus or minus the square root of something. And then finally, we get x by itself. Now it's a lot of steps, and it looks complicated. It's not really that complicated. The main thing we do is add b over 2 squared to both sides, and then we get x by itself. That's the big picture of what we're doing. good with our steps? Okay, let's look at a couple of examples of solving by completing the square. X squared plus 12x minus 20 equals 0. All right, so we're equaling 0, so we're good. A is 1, so we're good there. We don't have to divide by anything. B equals 12. C equals negative 20. Now, why would we want to solve by completing the square? If we tried to factor this, we'd say, what are two numbers that multiply to negative 20 and add to 12? And we think, oh, 10 and 2 would work. Well, one has to be positive and one has to be negative. Well, negative 2 plus 10 is 8, and 2 minus 10 is negative 8. We can't get them to add to the right number. So this would not factor the way we've been factoring. We couldn't solve this by factoring. That's one reason we might complete the square. All right, so my first step is going to be, I'll write it up here in blue, we're going to add 20 to both sides. We're going to get C on the other side of the equation. So I end up with x squared plus 12x equals 20. Well, B over 2 is 12 divided by 2, which is 6. And B over 2 squared is 36. So I'm going to add 36 to both sides. So I get x squared plus 12x plus 36 equals 20 plus 36 is 56. Now I'm going to factor this. This is a perfect square now. That's why we added the 36 here to make it a perfect square. This is going to factor to x plus b over 2 plus 6 squared. And that equals 56. When we complete the square, it always factored to x plus b over 2 quantity squared. Now we take the square root of both sides. I'll write a blue square root here to show what we're doing. Taking the square root of both sides. The square root undoes the square, so we get x plus 6 equals, and I'm going to write this as plus or minus the square root of 56. Need a plus or minus when we take a square root. Now, a lot of times in your book and on the worksheet that we're going to do for our homework, they will leave this as plus or minus the square root of 56. So my answer, when I get x by itself, I'm going to subtract 6 from both sides. And I would write x equals negative 6 plus or minus the square root of 56. And that is fine for an answer. If we wanted decimals, we would say, well, the square root of 56 in our calculator is about 7.48. So we could say x equals negative 6 plus 7.48. That's what the plus means, which is 1.48. Or x equals negative 6 minus 7.48, which is negative 13.48. Those would be our decimal answers rounded to the nearest hundredth. This answer is fine. These answers would also be fine if we wanted decimals. All right, so what we did was not complicated. There's just several steps that are involved with solving this equation. But the big thing that we did was take b over 2 squared and add it to both sides of the equation. That's what let us write this as a perfect square, and then we can take the square root of that to undo the square. And one reason that we would decide to do that is because this won't factor the way we've been factoring. All right, let's look at another example. And then we'll do one from our worksheet together. Solve by completing the square. Four x squared minus 8x minus 24 equals 0. Well, I'm going to say here we have a is 4. So we got to do something about that first. A equals 4. So we're going to divide everything by 4. So I'm going to divide this by 4. I'm going to divide this by 4. I'm going to divide that by 4. And I'm going to divide that by 4. Everything divided by 4. When I divide 4 by 4, I just get 1. Negative 8 divided by 4 is negative 2. Negative 24 divided by 4 is negative 6. And 0 divided by 4 is 0. Now I can work on completing the square. I'm going to add 6 to both sides. So I get x squared minus 2x equals 6. And here I have b is negative 2. So b over 2 is negative 2 divided by 2, which is negative 1. And b over 2 squared is negative 1 squared, which is positive 1. So I'm going to add 1 to both sides. X squared minus 2x plus 1 equals, I'll write that step here, plus 1 plus 1. Move that up here, plus 1. Equals 7. So I found this number and I added it to both sides. This now is a perfect square. That's what adding this 1 does for us. This is going to factor to x plus b over 2. So that's plus negative 1, x minus 1 squared equals 7. Now I can take the square root of both sides. Square root undoes a square. I get x minus 1 equals plus or minus square root of 7. Your book will often leave the answer like this, and the worksheet does. We still need to add 1 to both sides to get x by itself. So my answer then I could say is x equals 1 plus or minus the square root of 7. That's fine for an answer. Square root of 7 is about, if I put that in my calculator, square root of 7 is about 2.65. So we could say x equals 1 plus 2.65, which is 3.65. And x equals 1 minus, or x equals 1 minus 2.65, which is negative 1.65. This is fine for an answer. These would be fine for an answer. questions there? Okay, so our homework is just solving by completing the square. And there's also a puzzle on here, so our homework is a worksheet. I'm going to stop this and I'll pass that out. And then I want